everyone, my name is Isaac from the Innovation Consortium, and today I would like to share with you about thread cutting, what threads are and how to cut them using a lathe machine. There are very many ways of cutting threads. You could use a tap, you could use a die, you could use a pipe thread cutter, very many other ways, but today particularly we are going to concentrate on how to cut threads on a center lathe machine. To start with, what do we need to cut threads on a center lathe machine? I have some components here. On a lathe machine, you need an orthogonal cutting tool or a V-type cutting tool. It could be high-speed steel, it could be carbide, or any other tool bits, but they should be orthogonal when you're cutting V-threads or any threads on lathe machine. We also need this tool here. We talked about it in our episodes, but it's called a thread pitch gauge. This one is the one which gauges the pitch of the threads you're going to cut. Once you have a sample, take for instance a screw. This is an M16 screw. You trace or you look for the pitch of the threads. By the pitch, I mean the distance between two corresponding threads. So we measure the pitch by inserting these V-form gauges into the grooves of the screw actually. So the other thing we need, it's the lathe machine itself, because it's the machine which cuts or which performs the operation of thread cutting. So to look at the machine itself, right here, the machine, it's the center lathe machine which we are going to use, or which we are experimenting how we cut threads on it. To start with, whenever we are cutting threads, we concentrate more on the direction of the threads, the type of the threads, and the pitch of the threads. What do I mean, the type of the threads? We have threads, metric threads, and we have imperial threads. So those are two most common types of threads we cut on the lathe machine. So the tool also depends on the hardness of the material we are going to cut. That's when the tool changes from maybe high speed to tungsten carbide to engage or to handle harder materials. Then the other thing is the pitch of a screw, and the pitch, we are always able to set the pitch on the lathe machine with the help of this chart you're seeing over here. This chart, most of the lathe machines come with this chart, and the chart is engraved with all the marks or with all the pitches, be it in inches or in millimeters. So whichever pitch I want to set, or whichever pitch of a screw I want to set, I'll have to refer to this chart. So as I set these gears to ascertain the pitch of a screw. Take for instance, I have a screw, it's of M16, but I don't know the pitch. I don't know the distance between these two corresponding threads. So I'll have my pitch gauge. It has the metric side and the imperial, or the Whitworth, the imperial side. So I'll be flipping the gauges on the metric side, and all the numbers are engraved on the different gauges, as you can see. However much I flip, all of them are engraved, so you can trace for the pitch you want to cut on the lathe machine. Now take for instance this one. If you don't know the pitch, then you have to trace for it from these gauges. The pitch of an M16 screw is 2.0, as you can see. We are having a 2.0 on the thread pitch gauge, meaning on our chart here, there must also be a 2.0 somewhere, so we have to look for it in the metric area or in the metric demarcation in the chart. So M16 by 2.0, you might find another design of a thread, maybe M16 by 1.75, so you have to confirm with the thread pitch gauge. So this one is 2.0, as you have seen, it's 2.0. So we shall have to look for a 2.0 on our chart, basically. The chart, it's having demarcations of the metric and the imperial threads. And the metric, they are all labeled threads per inch and threads in millimeters. So you just have to shift to the particular demarcation or the chart to the standard of the threads you want to cut. But before we even go to the chart, we have to first set the gear train. By the gear train, what do I mean? All lathe machines have a gear train at the bottom left or at the extreme end of the headstock. When you open this cover you're seeing here, there is a gear train inside. This is what I call a gear train. It's an arrangement of gears. So before we refer to the chart, there are some settings we have to set on the gear train to ascertain either imperial or metric threads. So basically, what does it show us on the chart? The chart has arrows. There is a bottom arrow and the upper arrow. One arrow will be looking any side depending on the type of thread we are cutting. So take for instance, if we are cutting threads in inches, the arrows are showing. One arrow, the upper one, shows it's pointing leftwards, and the arrow at the bottom, it's pointing leftwards, meaning the gear up, it's the arrow up, and the gear down, it's the arrow down. When the upper arrow is pointing leftwards or inside, it shows this gear has to be inside. When it's pointing leftwards or outside, it shows the gear has to be outside. Same applies to the bottom gear. When the arrow is pointing inside, it shows the gear has to be inside. When it's pointing outside, it shows the gear has to be outside. And how do we achieve that? These gears, they come with a grab screw in it and a sliding shaft. So the gear slides onto the shaft to either go backwards or inside. Once you loosen this grab screw you're seeing here, some of them are Allen capped, but this one we use a minor screwdriver to loosen the grab screw. So once you loosen it, the gear moves freely to the left or to the right. But take note, whenever we move this gear, it should be engaging with either the two of these gears on the gear, on the idler. We have an idler for it, it doesn't move any direction. For it, it's static. But whenever we move either the bottom or the upper gear, we have to engage those gears onto the idler. So right here you can see this one should be meshing with this gear here. So once they mesh, they are transferring a drive from the headstock to the lead screw, basically. This is the lead screw we are seeing here. So they are transferring the drive from inside the headstock to the lead screw. This shaft, it's the lead screw. This one comes from the headstock or the gear trains inside the gearbox. So we shall be experimenting with a pitch of 2.0 because it's the screw. We've seen it's M16 by 2.0. We come here, knowing it's 2.0, that means those are metric threads. When they are imperial, you gauge with the imperial size. Take for instance like the pipe works or pipe joints. The most pipe joints or pipe threads are imperial. So whenever you come across a pipe, the gauge or the pitch gauge, you'll gauge those threads, mostly you'll gauge those threads on the imperial side. But when it comes to screws, yes, they are imperial, but right here, the one we are having at this particular moment, it's a metric type. So we shall come to the chart after setting the gear train. We come to the chart to see where we achieve the 2.0 millimeters of a pitch. But before we go to the chart, the safety precaution when setting the gear train actually, you should make sure the switch, the main switch is off, because once the machine starts or anybody starts the machine, the switch, the machine will start running automatically. Good enough, our machine is having a limit switch. For it, once you open the cover, the limit switch switches off the machine automatically. But there are those machines without this component here, without a limit switch. For them, if anybody comes from anywhere and switches on the machine will start running at the start, will start running away. So you might end up getting injuries from these gears. So basically, make sure you switch off the main switch behind the panel. So we go to the chart basically. The chart is here. We are having imperial threads and we are having metric threads. We are cutting metric threads. So we have to go to the chart, the portion where we are having threads in millimeters. We look for a thread pitch of 2.0. 2.0 here on the chart. It shows 2.0, it's C3 by M3, C3 by M3. So we come on these knobs. They are the ones which set the speed of the lead screw. These knobs you're seeing here, they determine the speed. They reduce or increase the speed of the lead screw, getting the drive from the gear train. So we say a pitch of 2.0. Here on this chart it shows it's aligning with 2.0 vertically and horizontally. It's an M3. So we go for M3. These two knobs, they have marks inside them. If you can zoom in or come closer, we see. An S stands for feed, and an M stands for pitch. So there is an S and an M, as you can see. There is M and S. So this one is for feed, the speed of the feed, and this one is the pitch of the lead screw. So whenever we are cutting threads, we turn an M, we expose an M, or we set the lever to an M, showing the pitch of the lead screw. Then here it showed us M3, meaning here they are Romans from 1 to 5. So we set to 3. 3 is M, then I. So we shall shift to I. So for this type of lever, once I pull it out, I can shift the screws from the lead screw to the feed screw, or from the feed screw to the lead screw, depending on what I want. Now particularly right now, we want threads, so we pull it out it engages, then we move to the lead screw. Then once I push it inside, I'm also setting the pitch still. It shows M-I-I-I. Then I push it inside, I shift to I-I-I. There are 3 of them. Then there is another knob. This one, it shows A3. So I'll have to set A at the outer part, then 3 at the inner part. So here it's already in A, but it moves to very many different alphabetical letters. We have A, C, up to F, I think. So here we are having an A to 3. And I push inside, I set to 3. So once I set that, that means I'm already having a pitch of 2.0 on my lead screw. But if you can take a closer look, our gear, we had not moved it to the inside. Meaning right now, the threads I'm cutting, they are imperial, they are not metric. So I'll have to shift the gear back inside. As you can see, it meshes with the idle gear, then it picks a drive from the headstock. After that, we tighten the grab screw so that it doesn't move. In the process of cutting threads. So once I set, we lock our guard. We lock our guard, then we set our blank or our workpiece in the machine. Then after setting our pitch from the chart, then we get our blank. This is the material. We are going to cut the threads on this material, on this blank. But first of all, we have to set the material in the chuck. So right here, we are going to set the material or the blank in the chuck, basically. Now, as you can see, our workpiece is already set. It's running concentrically, so it's already balanced in the chuck. So all we have to do is turn to the major diameter. Always we turn the screw, the major diameter of the blank first. This is M16. If you measure with the caliper, the outside diameter is 16 millimeters. So the outside diameter of the screw is 16 millimeters. So we have also to cut the blank or to turn the blank to 16 millimeters. That is the major diameter or the outside diameter of the screw. So that is the first step we do, basically. So right here, we are turning our blank to M16. So we are turning the outside diameter of this shaft, or the blank we are cutting, to 16 millimeters. So as we turn, we always confirm the diameter we've reached on. So right here with our vernier caliper, we measure, it's showing 21. So we still have some more 5 millimeters to go. So we still cut more 5 millimeters. Feed 5 more millimeters. And as well take 2 to 1 millimeter, depending on the hardness of the material and the feed we are taking. So basically, till we reach 16 millimeters. So that's how we do it. Yes. So right here, we are taking our final cut of the outside diameter of our blank to ascertain the same size of the screw. Remember, our screw is M16, so we need the outside diameter of our blank to be also 16 millimeters. So we take the measurement with the vernier caliper. As you can see, it's showing 16 millimeters basically. So we have to take this cut to the end, then after that we shall start cutting our threads. So this is the size of the screw. Then if you gauge it to see the diameter, whether we have achieved it. So once you gauge it here, it shows the diameter is more or less, actually it's the same. It's the same diameter we are having. So the remaining work is to cut the threads. After the final cut, then we'll be able to cut our threads of M16 with a pitch of 2.0. So after turning our blank, so normally when we are going to start cutting threads, we put on a chamfer at the start of our blank. So I will tilt my tool and put on a chamfer at the start of the blank. As you can see, I tilt my tool to that angle so that I can put on a chamfer on our blank. So that's what I mean by a chamfer. So normally all threads, all screws, be this completed one, you can see at the start of the thread there is a chamfer normally. So after putting on the chamfer, then we put on our orthogonal cutting tool or the V-type cutting tool on the tool post, so as we start cutting the threads. So after tightening our orthogonal cutting tool or the V-type cutting tool, we tighten it in the tool post as you've seen with the help of these screws. Then we are good to go. We are good to start the threading process. But before, there is a carriage here. We have a half nut which we engage before we start the threading process. So we shall have a closer look at the half nut and its importance, then we start our thread cutting. So after turning our blank to a 16 millimeter diameter, because we are cutting a screw of M16, we come back to our settings here. You take note or take caution of this hand knob. It has the left hand side and the right hand side. So the left hand side, when you turn it to the left hand side, we are cutting threads, right hand threads. When you turn it to the right hand, we are cutting threads of a left hand, basically. So it moves, the arrow points left, meaning we are cutting threads, left hand threads. When it goes right, we are cutting right hand threads. We can take an experiment or a physical view what happens whenever we change this knob. So right here, we are having our carriage, as you can see. So the machine is on. And our lead screw is moving, meaning we are cutting threads. So once I engage the half nut, this is the half nut which grips onto the lead screw. So it's a nut with threads of the same pitch as this one. So whenever you engage it, the threads grip onto the lead screw. When I disengage, the carriage stops moving. When I engage, the carriage starts moving as we are cutting threads. So, taking you back to the hand knob, which changes the direction of the threads. Once I change it to the left hand, as you can see, the carriage is moving backward. When I change it to right hand, the carriage is moving in front. So basically, it changes from left hand threads to right hand threads, depending on what type of threads you're cutting, basically. So that's the importance of the hand knob on the gearbox and the half nut, basically. So the hand knob, it changes the rotation or the direction to left hand threads, then right hand threads, basically. Then the half nut engages to the lead screw to give the carriage the frontward and backward movement when we are cutting threads, basically. I think now we are good to go and see how we shall be going with our threads. Remember, we have already set the pitch from the chart. We have already set our lead screw is moving. Our lead screw is moving. So after setting everything, the hand knob and the selector levers for the gear train of the lead screw. So we are good to start with our thread cutting. So we engage our half nut to get the carriage moving forward. So once it moves forward, we move the cross slide inside to give the tool a feed. As you can see, we have given our tool a feed. When it's almost reaching, we turn anti-clockwise. We switch the lever to the bottom so that the machine rotates anti-clockwise and the carriage goes back. So the process, it's a hand lever which moves the carriage in front and backwards. When I switch it, the carriage will move forward. When I turn it down, the carriage goes backward. So in the due process, we are cutting threads. But in the backward movement, we always disengage the tool with the cross slide, and in the frontward movement, we engage with the cross slide. So in the due process, we are cutting threads, as you will see. The cross slide moves the tool inside and outside. So inside we are cutting, then outside we are moving backward to get a new cut, basically. So here, as you can see, we are cutting, then we disengage, we turn backward, the tool goes behind, and so on and so forth. So we shall be cutting in that process. It needs patience. But first of all, Our first cut we take on the screw, we have to gauge it with a thread pitch gauge, because we said earlier on our pitch is 2.0 of an M16 screw. So we gauge whether it is 2.0 we are cutting. So once I gauge, as we can see, now here it shows the pitch is not aligning with the thread pitch gauge, meaning there is something wrong with our pitch. So we have to look where we went wrong when setting our pitch. So we have to go back to the chart and see what went wrong when setting our pitch. So we are having a wrong pitch we are cutting, and the thread pitch gauge is showing you that the pitch is 2.0, but what we have on our blank is not 2.0. So we have to go back to our settings and see what went wrong, where to fix, so that we get an exact pitch of 2.0. So after rectifying the problem, one of the lever had changed from C3 to A3, so we had to shift it back to C3, and we shall experiment and cut again to see whether we are having our pitch as we want, a pitch of 2.0. So the first thread I cut, it's one I use to gauge whether I'm having a 2.0 pitch. And here it shows, yes, we've managed to ascertain a 2.0 pitch. So the rest of the work is to do the process of thread cutting. As you can see. As you can see, we are already cutting grooves, the spiral grooves I was talking about, but they are of a pitch of 2.0. By the time they form a V, we shall be achieving a thread of this type, as you'll see as we go. Slowly, slowly. As you can see, we're already trying to achieve a V form of a thread. So we keep on cutting and clearing and gauging with a thread pitch gauge. We cut as we gauge. We see now our gauge shows it's remaining a little portion of grooving so that we can achieve the V to a standard of an M16 screw. So we keep on cutting, but we decrease on the feed since we are almost reaching to the depth of the threads. So at the end of the day, or at the end of the session, we have to achieve a thread where a nut can screw onto it smoothly, as you see this original one. So what we are cutting, we have to achieve this, and the nut can move smoothly onto the threads. So we shall see where we are so far. As you can see, the threads are already running, but they have some tightness, so we have to clear a little bit to achieve the threads which run smoothly as this original screw. So we do some clearing so that the nut will move smoothly onto the screw. So after the clearing, we try and tighten our nut. As you can see, it's already moving smoothly onto the screw, meaning we've already achieved our screw threads onto the screw. So that is the process basically. I hope you've understood the process. It's from setting the gear train to the chart, to setting the carriage, the half nuts, the hand knob on the headstock, then the orthogonal cutting tool, then cutting the threads. Basically that's it for thread cutting. So ideally, I remain Isaac from the Innovation Consortium. Thanks for watching. You keep tuned in for our next episodes of How To. Thank you very much.